Hello, welcome to our 2.4 module, rational functions. So a rational function is a function of the form y equals p of x over q of x, where p of x and q of x are both polynomials. Okay, now here we do have a little bit of things to consider when it comes to domain. So the domain consideration is that q of x cannot equal 0. Okay, so that is our domain consideration for rational functions. All right, let's go ahead and start with a few examples. Okay, let's take y equals 1 over x. This is a sort of very basic rational function. Okay, let's take a look at the graph of it. We've actually seen this equation a few times already. Couple things that we say about this thing. So first, as x goes to infinity, y goes to 0. What that's indicating is that as we move along in this direction in x, our y value is getting closer and closer to that 0 line. Okay? Similarly, as x goes to negative infinity, y goes to 0. I like moving these to be close to where it's happening. So as x goes to negative infinity, y goes to 0. Okay? Another thing that's happening is that as you're getting close to 0, you're going to go up to infinity there. But this is getting close to 0 from the right. So we're going to write for this piece, write it in orange. If I can get it. As x goes to 0 from the right, y goes to infinity. Okay? And similarly, what's happening down here? Or I'm sorry, there. As x goes to 0 from the left, y goes to negative infinity. So we put a little minus sign here to determine that it's from the left. Okay, now we could say that x equals 0 is a vertical asymptote. I'm sorry, no, that's right, vertical asymptote. And y equals 0 is a horizontal asymptote. Okay, so this is just sort of some of the language that we use to talk about rational expression. Okay, let's take a look at another. Let's take y equals 4x over x squared minus 8x plus 15. Okay, so the first thing that we're going to do is we're going to go ahead, we're going to factor that denominator. So we're going to write this as 4x over x minus 5 times x minus 3. Okay, so now we're going to have two problems in the denominator at 5 and at 3. So x equals 5 and x equals 3 are vertical asymptotes here. I didn't talk about the domain on the last one, but I could have. Here, for this one, the domain is negative infinity to 3, together with 3 to 5, together with 5 to infinity. Okay, so now let's go ahead and let's start graphing this thing. All right, so we're going to have at 3 and at 5, we're going to have asymptotes. Okay, I could have drawn those a little better, but oh well. Now, I'm going to go ahead and I'm just going to do a sine chart for this thing. Okay, so I'm just going to go straight into the sine chart. I'm going to list all my asymptotes and all my zeros in order. Okay, so zeros. Zeros are where the numerator equals 0. Okay, so in this case, whatever makes 4x equal to 0, that's x equals 0, of course. Okay, my asymptotes are what make the denominator equal to 0. Okay, so that's going to be x equals 5 and x equals 3. Okay, now I'm going to go ahead and do the sine chart. Sine chart, I'm going to have 0, 3, 5. Okay. The pieces that go along the side are 4x, x minus 5, and x minus 3. Okay, now, here I'm going to change things up a little bit, okay? The 4x is still going to get, you're still going to have a 0 at 0 for 3. But when I do the x minus 5, it's still going to be under 5, but I'm going to draw instead a little open circle. Okay, and the reason I'm drawing that as an open circle is just to remind myself, actually I don't like where that open circle is, but it's just to remind myself and you that x equals 5 had to be thrown out of the domain. Okay, and do the same thing with x equals 3 there. Okay, so all of these change from negative to positive in the same way that we did before. So for example, 4x looks like so, changes from being negative to positive. Okay. All right. 3 negatives gives you negative. 2 negatives gives you positive, negative, positive. Now, I didn't talk about the end behavior here yet. So let's just write that in. The end behavior. Well, what's going to happen as x gets really big? As x gets really big, the x squared is going to be sort of the dominant thing, right? X squared is much bigger than x. Okay, so I'm going to take the leading terms of 4x divided by x squared. I'm going to say that's 4 over x. But 4 over x, that goes to 0 as x gets bigger. Okay, so I sort of have a horizontal asymptote of y equals 0. Okay, so now we have everything we need to graph this thing. Okay, we have everything we need to graph this thing. So it's negative until this 0. Sorry, I should have put that in there. After the 0, it's going to be positive, and then it's going to have to go up, okay, because you can't change signs unless you have a 0 or an asymptote. Between 3 and 5, it's going to be negative. And then after 5, it's going to be positive again. Okay, so putting that all together, I'm going to hug this asymptote, have a little bump there. I don't really know if this bump is there or not. I just add it to make it sort of clear that it's going to go from being negative to positive there. Okay, it's going to be negative between 3 and 5. Think about it, that's the only way that this thing can be negative. Okay, there's really no other way. I mean, you may have some crazy stuff, but you don't here. But it's just got to stay negative. It's got to be down at negative infinity and go down to negative infinity again there. Okay, and then finally, it's positive after 5. Okay, so this is sort of a sketch of the graph for our original equation here. Okay. All right, let's go ahead. I'll go to the next video next.